Hi, folks. Welcome back. This is episode 2 of Emergence Technical Chats. My name is Vivek Haldar. I'm your host. I lead some of our AI engineering teams here at Emergence. And today I want to talk about web automation and web automation AI agents. And let's go around the room for a couple of quick intros. So, Tamer, why don't you start?
Sure. My name is Tim Rosa. I've been at Emergence for, we'll be closing up on 5 years now. I'm one of the principal engineers here, and I'm just building agentic systems.
I can go next. My name is Deepak Akil. I've also been with Emergence for slightly over 4 years now. And been focusing on web agent for about 2 years now, roughly, give or take.
Thanks.
Awesome. Yeah, I'm really looking forward to this conversation because Tamer and Deepak, you were both the main creators of Agent E, which was Emergence's state-of-the-art web automation agent, which came out, was it mid 2024? Seems like a long time ago, before web automation agents were cool.
Yeah.
March last year was March 2024 is when we did the first cut on open source, I believe it was.
Yeah, it was
Wow,
one of
that's
the
like
earliest systems. It was before Operator or any of the other Mariner and all the other systems existed. So
that's like a few years in AI time. So let's go back to the beginning. This was obviously one of the earliest web agents. SOTA at the time, I still think it's pretty high on the leaderboard in terms of the various web automation benchmarks. But tell us a little bit about the origin story of the web agent. It was called Agent E. How did you even identify the problem and take the approach that you did to web automation at the time?
Yeah, maybe I'll start and I'll kick it over to you, Deepak. 2 years or so before that, I was leading the work that we're doing in the part of the business where we were inside the education technology space, and we were doing automation for teachers in the classroom. And that basically looked like the teacher has a remote control. She gives a command. Off that goes to do some automation on her machine. And the teachers were just so happy with this thing. They're using it in the classroom. They're hands-free. They're walking around. It was working great. The problem is that every time that we wanted to support something new, whether it be a new command or a new website, we had to basically create a custom workflow for that. And the reason behind it was we were using a system that was based on something like a dialog flow, which is a product from Google that essentially you take a command, you dissect it, you pull out the intents depending on the intents. What's the action? What are you operating on? And you're really dissecting the command and so forth. And based on that, you map it to what you want to do with it. Now you have a site. So you've got this new site that you're looking at, and someone said open something. Okay, if it's a link or something, all right, that's standard. But the moment that you want to get into deeper functionalities, like some of these other teachers had lots of sites that they just rely on going to all the time, we had to write a brand new automation. So I was leading that team, and every time we had to do something, it just was not conducive. It was very painful to deal with. The idea was when GPT 3.5 was coming out, some of the LMs were just rising. Deepak had dealt with something similar, and I go to him like, man, I think this whole thing can be redone with just some very simple actions. What do you think? I was like, yeah, I think the same thing. And Deepak, just being the person that he is, let's take an action. Let's give it a try, and then we'll talk about it. And he kind of did an early version, and then we thought maybe there's something here. So we ran to our CTO, and I was like, about a week between this one client when we're supposed to get back to us and when the next action we're supposed to do with him. We take that week and try something out. Okay, fine, go. We have an itch we want to scratch. That's what I think that's what I said to Ravi, our CTO. And Deepak, if you want to take it from
yeah. And this was well before the time, so more roughly the time where ChatGPT was starting to gain popularity and vision models were not that great. And the biggest challenge we had was that, okay, a website is huge when you think about it from a pure token count perspective. A YouTube, if you just take every single item on the HTML of YouTube, for example, it's 500,000 tokens. So it would exhaust the context window of any LLM at that time. So one of the key things that we brought to the table was the notion of DOM distillation, the idea of, hey, from this huge DOM, we don't need everything. Not all of them are equally important. Some of them could be important given some certain tasks, but then given a task, hey, how can we compress the DOM to the most relevant items so that can easily fit into the context window of another. So then for a certain task like search something on YouTube, the token count that we were interacting with went from 500,000 tokens initially to probably a few thousand tokens at best, which the LLMs were extremely good at reasoning and interacting with. And the first version of the web agent was very simple. Given a task, the job for the LLM was tell me what's the next step I should do. And we created a bunch of very simple skills like click on this element, enter text on this element, double click, and all those very simple things. And we just saw magic happen right in front of our eyes. It was fantastic.
Yeah, I think we had 5 skills, maybe less, down distillation being one of them. And I just remember the two of us, me sitting in the same spot here. And the two of us were just like, I can't believe it's actually doing this. This is actually clicking. This is actually going. It was multi-step and it would go forward. And of course, yeah, there were limitations, but it was doing the thing that we had to create so much. It would take a team of 2 people a week to implement this workflow, get everything going. And it just was mind-boggling. This is actually just working.
Yeah, and it's really interesting how all these patterns for building agents, things like planning, decomposition into subtasks, sub-agents, skills, all these patterns, now the community of engineers building AI agents are familiar with all these patterns, but these were all not well-established patterns back then in early 2024. Talk a little bit about these abstractions for building AI agents and how you were basically uncovering these abstractions as you were building a web agent, but now all these techniques are applicable to building AI agents in general, not just web agents.
Yeah, I think so. As with anything, the problems that occur when you put something out in front of people, they're always asking for the next thing. Can it do this? Can it do that? What about this? And we realized very quickly that if you're trying to string together multiple different things you want to do, so let's say 5 actions, 6 actions, that seemed fine. But the moment that you had to go to a page, analyze it, and based on that, go to another page, and from that, reference something that you did before, we started to see the context window was getting oversaturated. And because of that, even though this is with distillation and everything in the picture, we started to, it's almost when in human terms, we say, I'm just to the max. I'm overwhelmed, like mentally, I've had it, context overload. And that literally what was going on. So at the point, this is when we started looking into, I think Deepak, you're going to probably talk about the hierarchical planning because you were starting to go with that.
So basically the limitation of the first system that we had, which was one step at a time, one single execution loop, it would do well for short range tasks when the number of steps were like 5 or 6. But then as soon as you got into long horizon tasks where you had to go through multiple websites, interact with multiple things, extract multiple levels of information, then we started seeing that, okay, now it's starting to break. And we had a bunch of benchmark tasks that we were evaluating it with, and we noticed that, okay, in these long horizon tasks, our agent today is not so great. And the first thing that we tried out was, hey, let's create a hierarchical agent at the higher level, and then the inner loop, which is responsible for the execution, that almost becomes like a helper. It's almost like you have a helper and you are interacting with it. Hey, can you go to this website? Okay, now can you do this next subtask? And now can you do this next subtask, so that it's overall cumulatively that it accomplishes the same task, but then at each point, both the high level agents and the execution agents, memory is not overwhelmed. And that worked very well. That's its limitations as well, which we'll maybe get to. Just with this higher level planner and in an execution loop with the separation of information, that the higher level planner has the long horizon information and the inner loop is only aware of, hey, how do I get to complete this subtask. And that worked very well. And that's the architecture we had for the paper that we wrote, which had all these distillation of all these insights that we had. Hierarchical planning, change, observation. The idea being that you execute something, hey, you see the observe the change, and then you report it back to the LLM. That also improves the loop.
Yep.
Yeah, that was really cool at the time. You guys wrote a paper about Agent E. It's actually open sourced. It's on a GitHub. We'll leave links to all this in the description below. Couple of things I want to double click on. One is you mentioned DOM distillation a couple of times. So can you describe that in a bit more detail and why was that such an important technique?
Yeah. So the driver for it was that you have so much on the page. As a human, when you look at a page, your eyes go towards certain things. You're looking for certain things. And the notion was, if I'm doing the same thing, but now I'm looking at the DOM, underneath what a web developer they've layered in the HTML so much stuff. So you get into something very simple as, okay, JavaScript, let's toss the JavaScript out. We don't need to look into those. Let's toss those out. But then you'll get into something as simple as, here's a button. And the way that someone has represented this button, they've made a div, and inside that div, there's another div, and then there is a picture, and then there's some text, and then there's some other div because they wanted the text to span this way and that way. It's just a button. At the onset of it, we decided to go with accessibility trees. The purpose of an accessibility tree, it's the same thing that technology for screen readers uses. And screen readers, they're just focusing on the screen. I remember Deepak, when he found this, he's, with screen readers, this is the same thing. Oh, this is great. It's exactly what we want to do. We want to give the LLM that doesn't have vision the ability to read the screen. So let's go with that. The problem is with accessibility trees, they were missing a lot of information that we need. They decided what's important, and this is something that you get for free out of the browser, but we miss out on some things that we wanted. So the idea was, can we marry the two? Can we go through, and even with the accessibility tree, there was still some stuff that we need to prune out. So we had to basically go through and visit one node at a time in that tree, which sounds like this is very intensive, but it happens very quickly. Like, computers are very fast at doing this stuff. You could not parallelize it either, because if you're going to break things up, then it becomes a bit of a, you said here this wasn't valid, you don't need this node, but here you think you need it. So we had to really just walk through the whole thing. And so we go down, visit one node at a time. If this is a valid node, can we lump it up with something above it? Can we shrink that tree? And sometimes we have to do a little bit of an iterative. After you compress it one level, can you go again? And then we would go back and find that same node into the HTML and pull certain elements from the HTML. So over time, we started to learn there are certain aspects of an HTML, certain attributes that are very powerful. And there are patterns that web developers have built over time. For example, test data ID. That's an attribute. Seems so arbitrary, seems so useless, but developers seem to put a lot of information inside that. And the LLM, it knows what HTML looks like. It knows what JSON documents look like. So we actually ended up taking the HTML and turning it into a JSON equivalent, because a hierarchical JSON. This way we could actually control what is going in there, and we can help the LLM to understand what is there. So essentially we turn the problem into, you have a JSON document and I need to ask you some questions about it. And that just seemed to work really well. As if there were all kinds of different prune this, that wasn't enough. Okay, you over pruned, and we had to keep adjusting that over time. But the basic of it is, that was pretty much it.
Awesome. The other thing we should talk in a bit more depth about is benchmarks and how you measured the web agent. So in the original paper, if I remember correctly, you were looking at Web Voyager. So talk a little bit about the state of benchmarks, like your opinion of the benchmarks. I know internally at Emergence, we've talked about the inadequacies of some of these benchmarks and whether they do a good job of representing realistic enterprise tasks. And that's something we've been thinking about, so stay tuned. But yeah, talk a little bit about benchmarking and what a good benchmark for web automation looks like?
I can take that. I think benchmarking any agentic systems is challenging. And especially with web automation, it's even more challenging because the web itself is very dynamic and very diverse in terms of all the widgets and all the capabilities, things you can do on the web. Initially, when we started, there were two types of benchmarks for the web agent. One was kind of like a completely sandboxed environment where you could create your own websites and you could execute tasks on it. And then there was like a golden answer of sort, which you could, for example, evaluate using an LLM. There were Web Arena, Minivob, and all those, a bunch of different benchmarks that were relevant for those. And then there's the other kind of benchmark, which is live on the internet. You perform tasks that are very representative that somebody would perform on the internet and you would see the results. But then the problem is that the results keep changing, right? Give me a 5-star hotel that's available from this time to this time on a website. It might change. The results are very dynamic. And then the challenge becomes that, okay, how do you evaluate it? And when we started, and I would say also even now, the best answer is a manual evaluation if you want very robust evaluation in itself. But then, of course, there are challenges because it's not scalable. And there is currently I believe there's no easy solution to benchmarking. In the best of both worlds would be a good approach where you have some amount of automated testing, but also some amount of manual evaluation for certain kind of tests. I think that's, in my opinion, the way to go.
How do you feel about the tasks in these current benchmarks? How do you think they're representative of more complex enterprisey tasks, or how do you think the benchmarks themselves should evolve?
Yeah, at least the most popular online benchmark is the Web Voyager, right? And if you can see the results, when we published our results, we were at 73% or so in Web Voyager. And then there has been multiple other players that has evaluated on the same Web Voyager and they have stated higher results. And oftentimes the assumption is that you run the same benchmark on different agents, the numbers that you get are comparable. But in reality, the numbers you get are not comparable, especially with the web-based benchmark. The reason being that people have different methodologies when they evaluate things. For example, certain evaluations remove certain questions because, okay, some of them have become obsolete and the benchmark itself is not maintained. And some of them, people consider, okay, this is an impossible task today, but that in reality, they are just difficult tasks and not necessarily impossible tasks. And then it often means that even though you are running the same benchmark on paper, you are running two different versions of it. And then there are other challenges that people are running it from different locations, right? And most of these websites have localization capabilities. And that would mean that certain things are easier from certain locations and a lot more difficult from certain other locations. And then it becomes, okay, is this then a fair comparison? Because you're running it, it's not really fair in that sense. Yeah, I think one of the key things that we're missing in the original Web Voyager paper and I believe all the live evaluations that are out there is the notion of, hey, how do I use it? What is the methodology? What should I consider? When should I rerun a task? What should I do when a CAPTCHA is encountered? Oftentimes, it's not like a web. I would say that it's when a website throws a CAPTCHA, you can either try to, as a web agent, you can either try to solve it, or then the more fair, transparent approach is that, hey, you let a human solve it, and then it becomes a human in the loop kind of system. And then oftentimes these evaluations don't have the human component. And then when certain papers have considered when a CAPTCHA has occurred, okay, it's a failed task, you could not complete the task, right? A CAPTCHA was, but then when you think about it, that was not the web agent's fault. And probably to an extent, solving it is not the web agent's purpose either. That those kind of things are less discussed when you, at the end of the day, all our graphs where, okay, this agent is slightly better than this agent in terms of maybe 3%. But then when you dig a little bit deeper, that, hey, there are these nuances. They are very different how they are handled CAPTCHA. And then, okay, are these numbers really comparable?
And a big part of this is that it stems from like lack of protocol. If there was a protocol for a benchmark, it would just say, okay, this is how you're supposed to do it. So then you'd be prepared to handle all these things. But I think also my biggest surprise was there was Web Voyager, I think, had 600 and something tasks. There's a human sitting there reviewing these. So even if you split this up, and I think that when we published this, I feel like we had 5 annotators or something like that. But the thing that we quickly discovered was one person says this is a pass, another one says it's a fail. So now you get into this inter-annotator agreement, doesn't look right. These are humans. They should have a high inter-annotator agreement. And then a big part of it is that just the English language, when we say things, they could be interpreted differently. So if I say, find me something that is on sale, someone hears that and be like, oh yeah, it's on sale. Someone is selling it. So on sale and for sale sometimes just translate differently. If English maybe is not your native language, or even maybe if it is your native language, and you just like, oh man, I'm on task 200 of this, let's go. Just to call it out for what it is. Humans are error prone for repetitive tasks where we don't excel at those. So we see a lot of that stuff, and we don't see that really discussed much when people are reporting results. So that was one of the things that Deepak and I had to combat quite a bit with our annotators to really make sure we go past.
That really impresses what a wicked problem benchmarking for the web is, because it's so diverse, it's so complex, probably one of the most challenging environments you could set an AI agent to work in.
Yeah, I remember I was doing some presentation. I always start my presentation with on the great wild web, the world wild web, because that is what it is. There is no protocol. HTML is a protocol. It's a language, but it's really very loose.
True. And
Oh,
if I can add a little bit more of my problems with all the web evaluations that has been published, there is also including ours, right? There is, in hindsight, we should have set a higher standard for transparency. We did our best, what we thought at that time when we wrote the paper. But then given, when I look back now, almost every evaluation is extremely closed. It doesn't explicitly say all the details that somebody can actually go in, do a proper analysis of, hey, was what you're saying actually correct? I believe for really reliable evaluations, one of the key things is absolute transparency of evaluation, so that a third party can go dig deep into the agent response and even perhaps agent execution trail and recreate your analysis numbers. And to be honest, there are very limited web agent evaluations out there today where you can do it. I would even say none.
There's even something that's a little bit nuanced in here that usually people never think about it when it comes to evaluation, which is the cost of compute. So I beat your benchmark. Okay, great. At what cost? Is it realistic? I remember when we were putting out our paper, Deepak insisted on, hey, we really should put this out. And then I was like, okay, yeah, that sounds great. Let's put it out. So we had put out what was the cost of compute, and it was expressed in number of LLM turns, how long the conversation went, number of tokens, etc. Now, if you got some sort of a high score, did you have to turn off the lights to the city in order to reach that score? What was the cost? Is this really realistic? Because at the end of the day, benchmarking for the sake of benchmark doesn't really help. But if it's benchmark because we're saying this technology is ready for general use, now we have to really consider that cost of compute.
yeah, I agree. Benchmarking and evals are probably the hardest parts of developing AI agents. So you're right to call out all these nuances and spend so much time focusing on it.
And I think
So,
domain specific evals are the way. Today we have generic evaluations. And when we started, at least with the offline evaluations, one of our observations was that, yeah, you can actually top the table, but then does it actually translate to real world computer usage, web browser usage? And our understanding was that it doesn't, because we had tried internally Web Arena and all those other evaluations. And okay, what does it really mean that you are really good at Web Arena? And it's the same now. Web Voyager and a few others, they are very limited in terms of diversity of websites and diversity of tasks even, right? Given the diversity of the internet, it's minuscule. And then we really need domain-specific evals that actually go to the heart of what your web agent is supposed to do in representative scenarios.
Can you tell us a sore spot for us dealing with all this stuff?
You have some really hard-won lessons there. So I want to zoom out a little bit because Agent E web automation really kicked off long journey for Emergence, and now we're building these multi-agent systems. We're orchestrating across multiple agents. We're doing dynamic planning, all that stuff. So really taking a lot of those techniques that were used inside the web agent and bringing them out to a broader domain. So now we have a multi-agent system where the web agent is one of the agents in that multi-agent system. So I want to shift the conversation a little bit towards in an enterprise setting when we're trying to automate or solve problems with a multi-agent system. What is the role of a web agent? We have all these kind of specialized agents doing certain things, like you have a data intelligence agent, a data science agent, et cetera, et cetera. How do you think the web agent fits into that enterprise context?
Yeah, if we think about a client and what they have, typically they have a lot of data, their own stuff. Then they, it's just all their proprietary things. But the reality is, because of how connected we are as just as a planet Earth, a lot of information is shared on the web. So for many of us, the source of information is to go and look it up on the web, fetch it from this site, from that site, etc. That is how LLMs were trained predominantly. Much of the information comes from the human knowledge, and human knowledge is captured on the web for the most part. The web represents the same as the data sources that someone else would have, but it is there and it's public. So it represents that component that businesses would not replicate inside their company because it's available there on the web. Why would I add all this stuff? Why would I take a shadow of the internet and stick it into my data center? So that it represents really just that whole, it's like that other database that you don't have because it's there and you don't need to store it. So we see that as the component that every business workflow that we've had to work with. There is always the element and we get this from the web. And that's where the web automation agent and the emergent multi-agent systems, that's the job that it fills in. It fills in that gap. Now, of course, there are some things that are not on, there are on the intranet where it's internally and the company has its own thing behind the firewall. Yeah, it's the same for that. The web agent, if it works out there, should work in here as well. And that's something behind a paywall or something of the sort.
Yeah. There will always be systems that you can interact better with APIs. But on the other hand, there will still be the other side where the only interface you have is the web, because it's created for humans. And then it's most of these enterprise systems, they don't go through dynamic changes in that sense. They have really long times before their systems get replaced and so on. And in an ideal world, if the web agent was perfect and it could do every task as fast, as accurately, I can even imagine, right? Why do you need an API-based system? You could do, if an AI could do everything on the web and do everything really well. In that case, you could do everything with one system. But then the reality we are in today is that API connector-based agent is significantly better in terms of accuracy, in terms of latency, and so on. And the web agent becomes like a backup where you don't have those mechanisms in place, where you only can interact with UI. Then, of course, you have web agent as the last mile agent for the long tail of tasks for which you don't have APIs and other ways of connecting.
It just goes right into that cost of compute, right? API is going to be most efficient. Yeah. You could still do it through the web, but it's not really compute efficient.
Makes sense. So reflecting on the journey a little bit, what do you think are the lessons that we learned from building Agent E, which internally is structured like a multi-agent system, and it's doing planning and delegation of tasks. Um, how do you think some of the lessons learned during the building of Agent E have carried over or not to this larger multi-agent system that we're building?
We've
And
had so many things. So many listeners ask me on the day. The day will be different. The planner certainly was a big thing. That was definitely there was this whole the purpose. The whole thing was this purpose built stuff. Like this was one of the biggest things. That make the part of your system that you're doing so purpose built. Because when we had this one agent instead of a multi-agent system dealing with the web browser, and it just could do everything. It could read the DOM, it could do this, and it was just way too much. But when we made a planner, and your job is to plan, don't worry about who you're talking to. You've got some subordinate who you're gonna just tell stuff to. And this other guy, don't worry about what the big picture is. You're just like, I keep thinking like a scene from The Office, big picture guy and the day-to-day operations guy. And the big picture should just focus on the big picture. And the driver, just focus on the driver. And that was, I don't think that was obvious from the beginning when we set onto this journey. And I think that was it was a key moment when you just see things just shift. I think domain specificity, you were calling this out before. I don't dig into that a little deeper.
And one of the things we had noticed, because the web-based tasks tend to be really complicated, and in terms of number of steps, it tends to be very long and so on, right? One of the things that we had learned early on is, hey, what kind of information do you put into the context window of the LLM has a big impact. Imagine that you have a lot of noise from all your historical steps, and that tends to make its reasoning go worse when it's supposed to do a task. And what we call it today, context engineering, right? Being very methodical about what information do you put into the context window of the LLM. That was one of our big learnings as well when we separated the concerns from planner and the browser navigation agent. Hey, let's be really methodical. And that also translates to more accurate task performance and so on.
Yeah, and one lesson for me was how quickly can you iterate? We've seen lots of teams, even within Emergence, because it's just the temptation is so there. Let me just write the thing from the ground up. Let's go from the bottom up instead of maybe using a framework. And using a framework is very helpful because it allows someone has already put a bunch of boxes for you. And you could start out by filling in those boxes. Let me go in and okay, I need an agent. Okay, what does that look like? It needs an LLM and it needs this and needs that. Okay, fine. Fill out that template. Just go with that. Oh, you can add skills. Great. Tools. Okay, fine. Register your tools. Great. Put all those in. I need another one. I need a new tool. How are you going to add that new tool? Can it be a one line of code? Because someone else maybe is going to write that tool, especially if you're working with teams with different time zones. That person wrote the tool and this person wants to use it. It's just one line. It shouldn't be more. Your iterations should not be more than a one line here or 2 lines there. And yet you have to play that back into history. When we first did this, it was pre-vibe coding, pre-LLMs writing good code, all this stuff. So we had to code this thing up the old fashioned way. Things are a little different now, which is I'm grateful for. But you had to really make sure that you could just iterate super quick. I remember just adding a planner or changing. When you think about it, these are conversational patterns. This hierarchical planner, and you've got the helper guy. So it is a conversational pattern. And I think AG2 kind of calls that nicely. Calls these things conversational patterns. If I want to switch it up from I don't want a planner, or I want to add yet another person, like a validator into the picture. If you need to redo everything you just wrote, you're just going to move that much slower. But if it's a matter of I'm going to create a class and I can inject it here because I could say add agent, just like I said before, add tool, the speed improvement that Deepak and I iterated on so many things of this. And the main reason we're able to go that quick is beyond that, you have a good engineer. It's because the system that you picked underneath that's supporting how good are you not of an engineer. It's just still that underlying system is really super helpful.
Yeah, that's a great insight. Yeah. And I know those are exactly the same principles we're using for our larger multi-agent system as well.
Another big lesson: the more the hierarchies, the more that your response that you're sending has to go through. So this is an issue that just plagued some of the systems that we create, because you have at the heart of it is that you have some browser driver that went to a page, pulled stuff out, and hopefully that's the stuff the user is interested in. Let's say you pulled out a recipe, a food recipe from some website, and you you have a multi-agent system, which means you have other agents beside the web agent. Let's say one of them is a report writer, another one is it's going to operate on get some things from a database, maybe another one's going to get preferences, etc. And the user comes in and they're asking for a recipe for something that meets some criteria they're looking for. This thing goes into the system. Oh, okay, this is a web agent. Great, let's send it down. So we're successful. Great. We did the first routing. Everything is good. The web agent did its thing. But inside the web agent, you have the browser driver and you have the planner. So let's say you fetched about 2,000 tokens. You're going to send that up to the planner. I don't care what you tell that planner. It's going to put its own spin on it. And if it's going to output exactly 2,000 tokens, going back to that cost of compute, you've now outputted that twice, and LLMs are output bound. So you've written 2,000 tokens at least twice at this point. You wrote it in a browser driver, you wrote it in a planner. And now you're going to send it up the stack. First off, you're not going to get 2,000 out of the planner. It's going to be much more shrunk down. And the content will lose a lot of fidelity. It's going to focus on the important things. When you look at something like ChatGPT, we're pampered with such rich responses that come back, sometimes a little too much, but at the end of the day, people like to see, instead of like here's 4 lines of what it is. No, I need to see the whole recipe. So you start engineering prompts and so forth, and prompt engineering is really not the way to make sure that the content goes up verbatim. And then now when you bring that up to a system above that is going to do its own spin on it. And God forbid you're going to send that to a report writer system agent. That's going to put its own spin on that. What we quickly realized is that if you want to pass things, don't let the LLM be the thing that's passing stuff around. Use the things that have taken more of a place, have taken their proper place in multi-agent systems like short-term and long-term memory, of how you actually start passing things. Transactional memory would have been called in the past, but short-term memory, let's just reference the thing you want to send back to the user and allow the last point to do that final, here's how it should be prepared for the user. So eventually it'll be returned as 2,000 tokens, but it's going to be done once because it's done on the source, not on I tell you something and he tells him something and he tells her something, and it's a phone game. And we should avoid phone games in multi-agent systems. That has been a challenge for sure.
That's well put.
Yeah, that's a great insight to get more reliable, more dependable input. You're right. Okay, so let's look towards the future a little bit. Of course, the web automation agent performs pretty great. It's got great scores on all the benchmarks. Looking forward, the work is never done. What are challenges in this area you're currently working on? What are the big open questions? What are the problems you're seeing?
I think there are three pillars of problems, and we have addressed them in some sense, but then I don't think we are perfect in any of these. So one is accuracy in terms of how, given a task, how accurately can the agent go do stuff. Today, you can give it very simple tasks like go to this place, execute some UI elements, interact with them, and give some results. It does pretty well. But then if you give it more complex, long horizon tasks, most of web agents tend to not do so well, even with benchmarks and so on, right? With Web Voyager, there are web agents that are like at 90%. But then one reason why it's at 90% is also because many of the tasks in the Web Voyager, which was reasonably complex when it was initially released, but then now they are becoming fairly easy in a sense that you can just do a quick Google search and you get the results right in front of it, because Google also has AIs that summarizes long set of tasks and then you get the results. Then, okay, it then becomes like an online search kind of task at best, but not necessarily the long horizon task where you actually need a web agent for. So in at least those tasks, we still suffer in terms of accuracy. That's definitely, so there's always room for improvement, right? When you compare it with the human, a web agent is nowhere really as close to a human operator, especially an expert human operator. And that's the level we want to reach. So there's definitely a gap there. And the second aspect is determinism. So given the exact same task, given we are working with probabilistic systems, right? Even small differences in a step can lead to large differences in outcome. So one of the easy way to make web agent really is give the exact same task to 5 different web agents and then have pick the best of 5 approach, right? Just because you're doing it 5 times, you tend to have higher accuracy if you do a best of n approach. So that's, we want to get to systems where given the exact same task, either it has learned from previous experience or whatever, it has the same, it goes to the same trajectory, performs in the same way. So that aspect is still lacking in all. And number 3, I would say, is latency, which there will always be tasks which are kind of offline tasks where you can take 1 hour, really, no problem. But then the other side of task would be, hey, there's a human in the loop task. There's a human that's actually sitting there waiting for you to complete. And in those tasks, every second matters. Latency is the third aspect that we want to work on and keep improving, basically.
Yeah, and some of to go like one layer below some of those under that umbrella. As I mentioned, a lot of DOM distillation stuff we were doing, we did it all through DOM because that was the modality that was most trusted with LLMs. Vision models have gotten much better. So working on each one of them has the pros and cons. Vision doesn't see anything below the fold when you're on a page. You have to scroll down, but you could take a picture of the whole page. Then things get a little bit strange when you do that at times. However, there are some nuances in the DOM. For example, you have a drop-down menu. That drop-down menu is not open. Or you have an item that's hidden by something else. If you have the DOM, that doesn't matter. We'll see that menu as long as it's on the dynamic menu. You'll see that menu. You'll see all this content. You'll be able to find all these markers that you're looking for. So the blend of the two, really to maximize that ability to actually work on a task, that is super. I think that's going to be one of the things that will demonstrate very powerful for us. So that's one area that we are digging into. As Deepak was mentioning, how do you know that you did something cool? This whole like element of validation and so forth. Just working on that. There is more that needs to be done in that space. And I think this goes for any agentic system. Really, the validation doesn't require a human. Whether it's offline validation, say, oh, this was good, I should do more like this, or if it's online validation to make sure that it's actually fulfilling what the user is asking for, it's very much necessary. And that's an area where we are actively working in. And then Deepak was mentioning about, to go hand in hand with this validation, is that how can I say I did this well? I want to do more like this. So the first time I went to the site, I stumbled in the dark. Imagine waking up at night and just running into things. And the next time I go through, I better not look like that. But how do you do that while not missing new content, new things that are introduced on the page? So those learnings and things, that's an area of having to balance that. And then finally, I think it's the notion of like self-play. There are a lot of these terms that we speak about in the AI space, but let's bring those into the reality and deployed and actually implemented into systems. And what does it mean for an enterprise site? I'm not talking about going to a site like GitHub or albeit that's useful, but maybe some enterprise site that behind the scenes is behind a firewall somewhere. Can I practice some workloads on it before I actually go live? And that becomes something that goes back to that cost of compute, right? They would make it very efficient for everybody. But also it goes back to determinism. It really touches on all those pillars that Deepak was talking about.
That's great. That's super insightful. So let's start wrapping up. And to wrap up, I want to ask you both a question. Like we said at the beginning, you've been building this AI agent and other agents for a long time now, especially given AI timescales. Can you wrap up with maybe 1 or 2 pieces of advice for other people, other engineers that are building AI agents?
It's a lot of fun. The framework thing, as I mentioned, like to me, that's pick a framework, pick something that you can easily iterate. You can always remove the framework down the line if you think that this thing is becoming not so efficient or it's getting in your way, you can always take that out. But you're going to have to iterate. You're not going to get that agent that you want, or especially if you're doing a multi-agent system, you're not going to get it right your first 2 or 3 tries. It's going to take some iterations, and you need to be able to move at the scale that a customer wants you to move, which is obvious for all domains, but more, there's so much there that you need to be able to, they're expecting the speed at which a company, let's say like OpenAI, is releasing things. And if you're a small startup, you may not be able to move with that speed because you only have so many hands. So using something that'll help you iterate very quickly, to me, is something definitely hands-on. Please do that. Do more of that. Going into forums like, for example, AI engineering, I think that's a great forum. Just going into places like that and just see how other people are doing it. There's just so many different ways of even just writing a prompt. I still am amazed when I see someone else's way of writing a prompt, and here I think I got it down. It's okay, I think that's better. And it has nothing to do with you learning that from an engineer. You could pick that up from a product person because they're probably better at it than you as an engineer writing those prompts. Get versed into that. Writing prompts, that's another thing. Make your prompts structured. Don't just write what's on your mind, because we've done that before and it has come to bite us in many different ways. Don't write prompts like you're telling someone what's on your mind. Write it as if you're writing code. Be disciplined, be structured in it, have a reason for why every line is there, so that if you want to take it out, there's an actual reason. And my last one is benchmarking. As much as I have all these gripes with benchmarking that we've talked about, it does help you to know what good looks like. So when you reach that, then you can identify what's your next rung in the ladder to climb. That also reminds you where your gap is to stay sober.
And I can add that a mix of both. If you want to iterate fast, you need automatic evaluations. Even if it's not 100% there, it's definitely useful. But then don't just use automatic evaluators. Have a fallback, manual evaluations after it. When you're, for example, just before releasing your product, always have a human in the loop and a more rigorous evaluation. But then while developing, when you want to make quick changes, go for the fastest approach.
That's great advice. That's a great note to end on. Tamer, Deepak, that was a scintillating discussion. Thank you so much. And thanks everyone for tuning in. And we will catch you next time.